Hello everyone and welcome to another scientific video with Depth Processor Productions, and today in this video we are going to discuss how to calculate the distance from the earth to the moon in a very easy method. First of all, I must have one request from all of you. If you have not subscribed so far to my channel, and please do it, because this particular channel is little by little providing you the knowledge that you are waiting for, and in very soon, in very near future, this particular channel is going to be one of the largest scientific vlogging channels in the world. And let's move on to today's video. Okay, how to calculate the distance to the moon. That's what we are going to do today. And here we have the earth, and we can take it as m1. The mass of earth is m1, and we have the moon here, and let's take it as m2. The mass of moon is m2, and we can take the distance from the earth to the moon as d, and then we can take the radius of the earth as r. We don't want the radius of the moon. And then we can take the angle, the orbiting speed of the moon around the earth, the orbiting speed of the moon as v. Then if the angular speed of the moon, the angular speed means how many degrees, how many radians will it rotate around the earth in 1 second. The angular speed of the moon is omega. So if the orbiting speed of the moon is v, and if the angular speed of the moon is omega, then v equals d omega. D is the distance from here to here, right? We know. Everybody who knows the circular motion will know that. Okay, good. So first of all, we can have one equation from the gravitational law, the law of gravity. Fg equals g m1 m2 divided by r square. Fg means the gravitational force, gravitational attraction made by the earth to the moon, and it's equal to gravitational constant multiplied by mass of the earth multiplied by mass of the moon divided by the distance to the moon square. And from this we can take, okay, first of all we can take this equation. Then we can have another equation using the rotational motion around the earth of the moon. From that we can use that Fg is equal to m2 v square divided by d. Fg is the gravitational force created by the earth, because to the circular motion around the earth, the moon needs a centrifugal force. That particular centrifugal force is provided by the gravitational attraction Fg. That's why we are using it. And Fg is equal to the centrifugal force of moon is equal to m2, the mass of moon, v square, the speed of the moon, divided by d, the distance of the moon. So instead of this v, we can apply d omega, so that we can take the equation again. m2 d square omega square divided by d is also equal to fg. Now we can make fg equals fg. Fg is equal to fg. G m1 m2 divided by d square is equal to m2 d square omega square divided by d. Now what happened? The mass of the moon will be cancelled out. M2 will be cancelled out. Finally, the equation will come when we make subject G. The equation will come as G is equal to d cube omega square divided by m1. Then, the next step, we are taking this m3 mass and we are calculating the gravitational acceleration provided by the earth to this m3 mass. For that, we are using again the law of gravity. Fg is equal to g m1 m3 divided by r square this time. G is the gravitational constant, m1 is the mass of the earth, m3 is the mass of this object, and r square is the radius of the earth. Why? Because this object is kept at the distance r at the surface of the earth. Okay. Then is equal to F equals ma. The mass of the object m3 multiplied by the acceleration, gravitational acceleration of it, g. So in here, m3 will be cancelled out with m3, and finally, if you make the subject g, the answer will come as g equals gr square divided by m1. Here, simple g means the gravitational acceleration at the surface of the earth, r square is the radius of the earth square, and m1 is the mass of the earth. Now what happened? Here we have one expression for g, here we have another expression for g, gravitational constant, and here we can take g equals g. So d cube omega square divided by m1 is equal to g r square divided by m1. Now the mass of the earth m1 will be cancelled out as well. M1 cancelled out with m1. So finally, when we make subject d, the d is equal to gr square divided by omega square cube root of the expression, cube root of it. Now, I'm asking one question. Do we know omega at the angular speed of the moon? Yes, of course we know, because the moon is completing one full revolution in every 28 days. So one full revolution means 2 pi radians. 2 pi radians. 2 pi radians. Then 2 pi radian can be divided by 28 multiplied by 24 multiplied by 60 multiplied by 60. This is the full amount of seconds that we have in 28 days. So this expression will give how many radians will it rotate in every second, radians per second. Okay, now we can calculate this part and we can apply it here. So G we know, we can calculate very easily using a simple pendulum the gravitational acceleration at the surface of the earth. R we know the radius of the earth. In a previous video we calculated the radius of the earth using the sunrise method, and now we can have the omega also. Now this one we know, this one we know, and this one we know. We can apply and we can simplify to get D, and let's move on for that part. So D is equal, gravitational acceleration is 9.81 at the surface of the earth. R, the radius of the earth is 6.371 multiplied by 10 power 6 meters, and divided by omega square is 2.59826 multiplied by 10 to the power minus 6 radians per second, and the square of it. Finally, if you take this part, if you calculate this part, you will end up with D is equal to 3.884173 multiplied by 10 to the power 8 meters. It means 388,470.83 kilometers. 388,470.83 kilometers means the exact distance from the surface of the earth to the moon, from the center of the earth to the moon. So we have calculated the exact value using the method. It means without taking any telescope, without taking any laser beam, without calculating any the travel, the time requirement for the laser beam to travel or anything like that. Only using the applied mathematics, we have calculated accurately the distance from the earth to the moon, and this is the power of applied maths. And okay, thank you for watching. Thank you for providing me a view, another view for my channel, and also another view for my video. And thank you all. And let's see you soon with another valuable video like this. And in next video, we are going to calculate the radius of the moon. And see you soon in there. Until then, wish you all the best. And thank you very much for watching the video. Thank you very much.